the curve C has equation y equals s squared minus 5x plus 4. It cuts the x-axis at the point L and M as shown in figure 2. The infinite region R is bounded by Ln, Lm, and the curve C as shown in figure 2. Use the fact that the integral of x squared minus 5x plus 4 ds is equal to 1 over 3x cubed minus 5 over 2x squared plus 4x plus c to find the exact value of r. Okay, so what we're going to do is this. First of all, we're going to look for the coordinate of L and that of M. So how do we look for the coordinate of L and M? You know, the curve C crosses the y-x axis at L and at M. So we're going to solve for this equation here. So we're going to have x squared minus 5x plus 4 is equal to 0. So we're going to factorize this. So I'm going to have this x. So I'm looking for two values such that when I multiply them together, I'm going to get 4. And when I add them together, I'm going to get minus 5. So those values are minus 1 and minus 4. So I'm going to have x minus 1 and I have x minus 4. So the product of these two numbers, minus 1 and minus 4, is 4. And the sum of the numbers, minus 1 plus minus 4, is minus 5. So that's satisfied that equation there. So therefore means that x will be equal to 1 or x will be equal to 4. So the coordinate of L would be 1, 0, and the coordinate of M would be 4, 0. Okay, so these are the coordinates. Now the next thing we'll have to do, we're asked to find the area bounded by R. So this is the area bounded by R, the area inside of this, between this line, the curve C, and the x-axis. But what we are going to do, we can utilize this point over here. So we can make use of the points over here. So the point over here is 5, and for meaning that the x value is y5 and the y value is 4. So what I'm going to do, I'm going to draw a straight line from here down to this to form a right angle triangle. So this forms a right angle triangle over this part here. Okay, so it therefore means that we can calculate the area of the triangle. So what we're going to do, we're going to look for the length of the line L to this point. So let me give a letter to this. Let me call this point, let's use any letter. Let me call it B. So the coordinate of B definitely would then be 5, the same value for S here, 5, and 0, because it passes through the x-axis. As the value for y there is 0. So we can get the length of LB. So the length of LB will simply be equal to 5 minus 1. That's equal to 4, right? Because this is 5, S value here is 5, and the S value here is 1. So the length of this is 4. And obviously, the height of the triangle will be 4 minus 0. So that will also be what? 4. So the area of this triangle, let's call it BNL. BNL will be equal to half base, that's 4, times the height, also 4. So obviously the height will be 8 squared units. So that's the height of that's the area of the triangle. The next thing we'll have to do is to utilize this and look for the area under the curve. The area under the curve would be this. The area under the curve will be the area between this curve and this other line here. So we can find the area under the curve, this area here, by using this. Okay, so we have already been given this, so there's no need for us to integrate this again. So on integrating this would have led to this. So because we have already given the integral, as you can see from here, then there's no need for us to integrate again. So we just plug the values. So we have to look at the end point of this area underneath this. So the end points would be, as can be seen here, would be 4 for the value of x, and this is 5 for the value of x. So it means that the point 1 over 3 s cubed plus 5x squared over 2 plus 4s has been integrated from the point s is equal to 4 to the point s is equal to 5. You see, notice that I have omitted the c from it because this time around when I put the point 4 to 5, it's now a definite integral. So we're using the definite integral. So definitely this is now going to be equal to, so this is going to be equal to, so that's the area under the curve. The area, basically the area under the curve is this, because we just needed to integrate this from 0.4 to 0.5. So this will be equal to, so I'll just multiply this up and have x cubed over 3. So we'll start with the first value here, 5. So I'm going to have 5 cubed all over 3 plus 5 times 5 squared all over 2 plus 4 times 5, then minus, I have to include that in the bracket because I have to substitute the value of 4 into the same equation again. So I'm going to have 4 to the power of 3 all over 3 plus 5 squared all over 2 plus 4 times 4. Okay, sorry, this should be 4, not 5, because we are substituting in the value of 4 this time around. So that's 4. So that's 4. So on expanding that, that's going to give us 125 all over 3 plus 125 all over 2. That's 5 times 5 is 5 squared times 5. That's 25 all over 2 plus 20 minus. So I'm going to have 4 to the power of 3 is 64 all over 3 plus 4 to the power of 2 is 16. And the 16 times 5 is 80. 80 divided by 2 is 40. This should be minus again here. This should be minus. Okay, and this should be minus. So from the equation, it's minus that we'll have here. So you can see it from here, it's minus. So I need to include all of that. So that's minus, 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 and this also should be minus. So that's minus. Okay, so plus 40, minus 40 rather, minus 40, minus 40, then we have plus 4 times 4, that's 16. So we can just take the LCM of this, and this. So I'll make this over 1. So when I make that over 1, I'm going to have the LCM. It's going to be equal to 60, 6 rather. The LCM of 3, 2, and 1 is 6. So 6 divided by 3 is 2. 2 times 125 is 250 minus 6 divided by 2. That's 3. 3 times 125. That's 375. Plus 6 divided by 1. That's 6 times 20. That's 120 minus. Then I'm going to have 64 all over 3 minus 40 plus 16 is equal to minus 24. So on working this out, the area, remember the area we are looking for now is the area of the underneath the graph. So if we work this at 250 minus 375 plus 120, it's going to give us minus 5. So I'm going to have minus 5 over 6 minus, so we'll work this out, 64 over 3. So I'm going to make this over LCM. So the LCM will be 3, and 3 divided by 3 is 1 times 64. That's 64 minus 3 divided by 1. That's 3. 3 times 24. That's 72. Okay, I'll put in the bracket. So this area will be equal to minus 5 over 6 minus, so 64 minus 72 is minus 8. Then all over 3. So we can work this out as minus 5 all over 6. And minus times minus is plus 8 over 3. So we can just work this out. So that will be equal to, the LCM of this is 6 Okay, 6. Then 6 divided by 6 is 1 times minus 5. That's minus 5. Plus 6 divided by 3. That's 2 times 8. That's 16. So that this is going to give us 11 over 6 squared units. So the area underneath this curve is 11 over 6 squared unit. And you know that this area is part of the area of the triangle that we just calculated. So to get the area inside of this, then we have to subtract this one out of it. Okay, so let me just work that out. So the area of arrow will then be equal to, we calculated the area of the larger, the whole triangle as 8. So that will be 8 minus 11 over 6. So when we work this out, this is going to be equal to, so we can find the LCM, 6. And 6, that's 6 divided by 1, that's 6 times, that's 48. 48 minus 11. So 48 minus 11 will be equal to 37 all over 6. That's 37 over 6 squared units. So that's the area of arrow.